Router itself can be a very good firewall if the engineer is really techy. We in Cisco we have a feature called zone-based firewall. According to me, it is from here the idea of having another device called ASA or a separate device called firewall might have taken birth. Right on router itself, we have zones based on which we will have policies, whom to allow and whom not to allow. So zones to which the public is connected will not be freely allowed to enter into zones in which our LAN is connected. Unless we permit traffic between these two zones, the traffic won't pass through.
Like core and DMZ, right?
Yeah, you can say that. I'll not talk about DMZ now. We'll come to DMZ later. That is slightly different from what I'm talking now. But I'm just drawing a diagram here. You see a router. This is connecting to internet. And here is LAN. This may be a multi-layer switch. From there we may have LANs, layer 2 switches. So we call this as access layer, distribution layer, core layer, something like that. Or a collapse core, this one, and this one is edge. So now this router can be a firewall, but it's simply a router. I can configure it as a zone-based firewall. By default, the routers, if there is a route available in the routing table, they will permit the traffic. But in zone-based firewall, even though there is a route in the routing table, not even a single drop of data, a single bit of data can go unless we write a policy to join these two zones. So we are going to create zones, and we are going to put this in one zone and this in another zone. Like you did VRF, no, in MPLS. When you have in different VRF, do they talk each other? By default, not possible unless you leak. Because you are from service provider background, you understand, these are all same story but in different names. But for security guys, they don't know what is VRF. So when we say zone-based firewall, for them it is like, okay, it's a feature, firewall feature. But when you say VRF firewall feature, no one accepts it because it's a service provider domain. There we focus on creating different control plane. That is true. See, there is a big difference between zone-based firewall and VRF. I'm not denying that. But the shadow of this object appears same for us. The real may be different. Two people of same height are standing. And the shadow will appear same, but are they same really? No, they are two different people. Two different person. Zone-based firewall and the VRF is like that. See, in VRF you have two separate routing table. Here it is not like that. Only one routing table. But they're not allowed to speak. Even though the route is available in the same routing table, in the same control plane, the control plane will not allow them to communicate. because they are.
One question before I go ahead. Sorry, this is. I just want to know what is the difference between a firewall rule, firewall policy, or what is it? Rule, policy,
Role-based firewall.
access list.
Hmm.
Are three is the same? There's no firewall policy. There's no firewall rule. There's no firewall access list.
Okay, we'll discuss that now. So before we get into the zone-based firewall, let us finish talking about what you are saying. See, there is some default policy on every firewall. Cisco has got their own default policies. Palo Alto will have their own default policy. Most of the policy will be alike, same with all vendors, but some variation will be slightly there, uh, different from one vendor to another. And then there is some variations in the default policy, the default firewall policy among vendors, but most of the firewall default policies will be similar. Now, what is that firewall default policy? Let us see first that one. Default firewall policy based on the experience, based on the usual attacks that was happening, common attacks. These firewall vendors have come to a conclusion that we are going to stop these traffic entering in. If it is needed for allowing the traffic, let the owner do that. But we, firewall company, we have decided to stop these type of traffics entering in by default because the attacks are happening because of these things allowed. So such protocols, for example, ICMP. Mostly people will think ICMP is used for pinging. It helps to check connectivity. All those stuffs are good, but there are different types of ICMPs. Using ICMP, lots of attacks. I'm not that good attacker, but it is said that thousands of attacks are available, possible, thousand different type of damages through ICMP someone can cause to a company. So even though ICMP is good to check the reachability, the damage that it causes is more bad than this good. So by default, firewalls don't allow ICMP packets to pass through. This is a default policy. Example. Like this, there are many protocols identified as dangerous by the vendor. Instead of me going and as a user going and blocking them, vendor says, "Don't worry, I'm your friend. I block all this for you. That is why you are buying this because I have done a lot of work for you already. Already the majority of attacks are identified for mitigation. I already put the codings there. That is what called as default policy, default firewall policy. That is one story. ACL is we are writing to include some policy, include some additional policy, or to deactivate those default policies. Not all of those default policies. Some of them you may feel like, no problem, allow this. By default, it is blocked. Vendor has blocked it, but you say, no, no, no. For me, it's okay. Please allow this particular. So you are cancelling the default policy by writing access list, because you, the owner, writes, the firewall will obey. It will override. What you write is going to override the default. So I have answered access list. I have answered default firewall policy. What is the other question you asked?
Rules.
Rules? Did you say firewall rules?
Yeah.
This is what firewall policy is. What are firewall rules?
Okay, this is one and the same, I think.
Yeah. Rule.
We sometimes hear this, right? Like, sorry, there is no firewall rule for this, so I need to create a rule for this.
Yeah, there is no policy for this, so we are writing policy, allowing the traffic. It's the same. 1 minute. So policies are what called as rules. When there is no rule available for telnet traffic, then you have to write an ACL allowing telnet entering into your network. So rules, policies, both the terms are same terminologies. Any other question that you have? All right. Now, this zone-based firewall is a Cisco's feature. As I already said, zone-based firewall is not VRF. Like VRF, like a VRF won't allow traffic from one VRF member to pass to another VRF member. Member of a zone cannot talk to another zone. But in VRF, if you leak the route, members of two different VRF can talk, like you did in this morning. In zone-based firewall, they are not at all in different control plane. So that's the big difference. There, VRF, they are in two different control plane. You take them and leak it inside so that the other control plane can reach the member of this control plane, the routes of this control plane. That is route leaking between VRFs. But here it is not VRF. It's not different routing table, not different control plane. It is single control plane, but because of the firewall feature, the traffic from one zone member is not allowed to pass through another zone member's path interface. This is cheaper firewall, I tell you. Very cheap. You can have a good firewall in a cheap price. This is not available on every Cisco router. For that, you need to have a security operating system. Zone-based firewall, if you will have security iOS, this feature is available for us. So when I have this interface in zone and this interface in out zone, I create two zone. Even though A and B routes are available in the same routing table, they are not allowed to ping unless you write some ACL or you write some policy map and allow it. We need to write policies. Same like this, what access list, firewall also does. I just told you, there is a default firewall policy. What is the default firewall policy? Don't allow ICMP. Because there is a lot of possibility of being attacked, getting attacked. So, see, firewall is dedicatedly designed for protection. Whereas this is a router, here what we are seeing is a router. Unless you enable the zone-based firewall, that firewall feature will not be there. But as soon as you enable zone-based firewall, the difference is here every traffic is denied. All traffic is denied, not only ICMP. In ASA firewall, not all traffics are denied. Telnet is allowed. Telnet is a management traffic. That is allowed. But ICMP is denied. But here, everything is denied. When you have two interfaces in two different zones, nothing is permitted. You need to write policy to allow these. See, whenever you install a server operating system, you might have seen everything is blocked. Server operating system I have seen. For everything, I need to give permission. Only then that service will be available for me. But a normal professional operating systems, professional or home edition or those things, Windows home edition, Windows professional, that's not the case. As soon as you install, you can do XYZ thing without any problem. But in server operating system, everything, we need to tell the rules. Okay, you can allow this traffic, don't allow that traffic. It will ask you permissions for everything. For you to become friendly with that operating system, it will take some time because it's a server operating system. Likewise, when I configure a router as a zone-based firewall, I have to think, plan, write down what all traffics that are needed in day-to-day life to be allowed. Make a nice document and then allow those things. Sometimes you may allow something thinking that this is good, so I want it. Of course, that is achieved. What you want, you are achieving. But using that same thing which you want, attacker also enters in. And your zone-based firewall says, I am going to allow this because the owner has allowed this. For example, you allowed messenger. But using that messenger service, some spyware is coming. Now, the zone-based firewall cannot identify that. How it knows? According to zone-based firewall, messenger traffics are permitted. How a zone-based firewall can say this is not a normal messenger traffic, this is spoofed one. It's not that clever. But devices like IPS can identify that this is not normal messenger traffic, this is spoofed one. This is an attacker's trick to get inside.
How do they identify the traffic based on header files?
Yeah, based on the appearance, they know how the signature knows how a simple, normal messenger packet will look like, how the header will look like, and what will be the size of each header, layer 2 header, what should be the minimum and maximum size, what should be the minimum maximum size of layer 3, layer 4. Signature knows it very well. Signature knows very well that the packet size cannot be more than this. But when it is a modified messenger packet, definitely there will be some abnormal appearance. The signature will match with that abnormal messenger type, and according to what ISP is configured. If ISP is configured to block such packets, that will block. If it is designed to reset the connection, it will do. IPS will do. Or if it is allowed just to raise an alarm and act as an IDS, just permit the traffic and just you raise only the alarm, because I just want to verify whether it is really an attack or appears to be an attack. So depending on the IPS policy, the actions will be taken. Let us not get into that now. We are talking about a router used as a firewall. Zone-based firewall is one of the feature in Cisco routers, in Cisco security iOS routers that we can use. So we are going to do a lab on this, and then we'll move on to the next topic. But today is not a lab day, so let us quickly move on to the next topic. We will do this lab in next class, so that you will know the reason why I'm doing this is you will know the difference between a normal router based firewall and a real firewall. The real firewall, the complete dedicated firewall, ASA, we draw like this. Only when you know what a router can do, you will know how important a ASA firewall is. How much it is different from a normal router based firewall. In router, this is the biggest thing that you can do as a firewall, zone based firewall. If you write a normal ACL, then also it is a kind of firewall, but this is the biggest firewall feature on a router. So when we go here and see a real firewall, how it behaves and how it mitigates and so on, the default policies, then you will understand how important is a firewall than a router being used as a firewall. Now let's talk about the ASA as a firewall. Adaptive Security Appliance. This one, you see, the name itself explains. It's a security appliance which has adapted too many things in it. So it is not simple firewall. It is also a very good router. It is also a very good layer 2 switch. It is also a VPN concentrator, meaning you can have many connections of VPN. See, every router has got a limitation of how many VPN connections you can establish. But ASA firewall also has got limitation depending on license, but again, it has got more and more the maximum support that it can for VPNs. Any connect VPN, site to site VPN, get VPN, all VPN. So it has got many appliances in one. That is why it is adaptive security appliance, ASA. Now, when you talk about firewall, zone, the word zone will always come. Let's say this firewall has got 4 interfaces. One interface I connect to LAN. Another interface I connect to ISP1. Another interface I connect to ISP2. Another interface I connect to a LAN COM WAN, meaning this portion of network is accessed by both inside members as well as the outside members, which is what you called earlier as DMZ. It is not fully militarized zone, it is demilitarized zone. It is demilitarized zone. People from both inside as well as from outside, they talk, they take some service, they reach. Whereas no one is allowed to talk from outside to inside. Not possible. If this is inside, the default policy is no one is allowed to talk from outside to inside. But outside to DMZ, if you make it as DMZ, when you write access list, yes, it is allowed. That is why you call it as DMZ. You are permitting. You're permitting the outside to come in. Inside will automatically go to DMZ, no problem. You don't need to permit and all. It will go by default, inside to outside. Sorry, inside to DMZ, listen. Inside to outside, permitted. Inside to DMZ, permitted. But outside to inside, not permitted. Outside to DMZ is also not permitted unless you write some policy. So if you want someone from the internet to talk to your inside, you need to write policy. You need to write rules to allow that. Likewise, if someone from outside wants to access this DMZ portion of the network, you need to allow the rules. You need to allow the policies, write the policies to let the traffic in. Whereas there is no need for writing any policy for those traffic that is going from inside to outside or inside to DMZ. No policy needed, no rules needed. No rules needed. Why? Because this is your firewall and this is your inside. You trust most. So no problem when inside is going to outside or DMZ. But outside is not you, it's someone there. In outside it is someone there. That someone may be good or bad. Yes, please.
Let's say all our web servers, will be hosted in DMZ, right?
Correct.
Yeah. So, okay. So by default, DMZ and LAN inside will be in one zone.
No. LAN and DMZ will be in different zone, but LAN is permitted. LAN is allowed to talk.
Okay, by default it is allowed, but if some subnets, if I want to block accessing these web servers, I should write a policy, is it?
Repeat again.
If it is by default allowed, allowed the subnets which are inside to access the subnets which are on DMZ. So if I want to block them, I need to write a policy.
Okay, I'll complete your statement now. You see, from LAN to DMZ, they're allowed. Now, if DMZ...
Sorry, Jay. When you say it is allowed, so all the ports will be opened, is it?
Yes.
443, 21,
yes.
Okay, got it.
Now, let me repeat your statement and complete it. I know it's not complete, so let me repeat your statement. LAN to DMZ is allowed, that's what I said. And your question was, if I don't want someone from LAN to access a particular web server here, do I need to block? Yes, you need to block. In that case, you will not first of all put them inside. Why you put them inside and then block them? Whomever you put inside LAN, which means you give permission for them to access the server because it's your own server, your own server. Why are you blocking for your own people? That's not a good idea. But if you want to, you should write an ACL denying this particular guy going to that zone. Now, other part of the story is, if someone from DMZ tries to talk to inside, not permitted whatsoever the protocol is. Listen, let's say A is talking to B because he's coming from inside, allowed to talk to DMZ. By default allowed. By default allowed. But can B talk to A? Can B initiate a traffic to A? No. B cannot initiate traffic to A, but A can initiate traffic to B and response will come back and response will be allowed. Repeating again. This is A inside. This is B in DMZ. When A tries to talk to B, B replies and the communication happens. No problem. How is that possible? Because he is going from inside, there is a stateful table. There's a table called stateful. It will make a record saying from inside, Mr. A is talking to the DMZ member B. So, when the return traffic of the same session comes from DMZ B to inside A, you permit. This rule will be dynamically written when you generate traffic from A to B inside to DMZ. This rule will automatically appear. How long this rule will be there? Permit statement will be there. As long as the session gets over. As long as the flow finishes. Once the flow is over, this will disappear. This will disappear because the flow itself is over. So that DMZ will not use that stateful table to come to A. DMZ cannot come in because there is no permit statement there. See how big difference is ASA and a zone-based firewall. In a zone-based firewall, you don't have this statefulness, you don't have this dynamic rules permitting the reply packet from B to A. When A is talking to B, a reply should come from B to A. A reply should come from B to A, which is in DMZ coming to inside. For that, rules need to be there. But the rules gets created dynamically in ASA because it was initiated from inside. Whereas in zone-based firewall, you have to do everything. You have to write everything. Okay, A is going to B. Now B will be replying. Permit B also to reply back to A. And allow only the reply packet. Don't allow the packet initiated by B. Allow only the reply packet. You need to do a lot of work. You need to be more experienced to do that. Whereas in ASA firewall, it's automatic.
the LAN and DMZ both are in different zones. Yeah. So the zone-based firewall comes into picture, right? No?
Zone-based firewall comes into picture, but there in zone-based firewall on iOS router, we need to write every policy. Zone-based firewall will simply block traffic going from one zone to another. That's all. Whatever you want to permit, you need to manually permit. Whereas here, it is not blocking. You see, you have a policy. What by default, the vendors found that from inside we should allow traffic to go out or DMZ because it's the owner sitting inside who is generating the traffic. There is no threat in it. It's the owner, so we should not block him. We should allow him. That is not the story with zone-based firewall. Whether you go from inside to outside or outside to inside, you have to permit only then the packet can flow. Everything you need to do manually here. Here, most of the things which are very commonly needed and which is found secured, safe, is permitted already here. So, in short, what I want to do is, I want to tell you in a simple way these things that I told about ASA firewall. That the moment you make, I'll draw a new diagram. The moment you have a firewall with a name inside, I am repeating. If you write a word inside, if you call a name of a zone as inside, whatever the interface may be, this may be G1 or G0 or whatever the interface, if you make that interface as a member of a zone called inside, that inside spelling may be like this, or it can be like this, a mixture of capital and small, or it can be like this, whatever. If it is inside, the word inside, that doesn't matter what uppercase, lowercase, mixed case you have. As soon as you configure this spelling inside, regardless of the case, it will consider that as a safe zone. It will give security level 100%, meaning it's a well secured area. You can be free. You don't need to restrict anyone. It's highly safe. It's highly safe. That's the meaning. As soon as you put the word inside as the zone name, as soon as you name the interface as soon as you name the interface as inside, this number will be assigned by ASA firewall. But when you give some other name, as let's say you are naming is outside, and here you are naming it as DMZ. Anything other than inside, the security level dynamically given is 0. Meaning, hey, don't trust those traffics trying to come in. Don't trust. Wait for the owner to provide permission. That's the meaning. It will not allow any traffic from out to enter in or DMZ to enter in unless you write rules. But when a traffic comes from here, it is freely allowed to go if there is route in the routing table anywhere. Because the traffic from high security level to low security level is permitted. Traffic from high to low is permitted. That's the rule, the default rule. Traffic from high security level to low security level is permitted. What is the other story of it? From low to high is not permitted. So to make this as a DMZ means we're now half trusted. So we manually give a number 50 so that traffic from high security level can go to low security, meaning a member of a DMZ can reach outside. So this B can reach outside, A can reach B as well as outside, but B cannot reach A. Why? B security level is lower than A security level. So traffic from high to low is permitted. So DMZ can go to outside. Inside can go to DMZ as well as outside. What is the other story? DMZ cannot go to inside. Outside cannot go to DMZ and inside. Outside cannot go to DMZ as well as inside because outside is 0. Low to high is not permitted. What I have explained to you is the fundamental, the real important beginning truth about firewall. The foundation. This is the foundation on top of which there are many things they have built. The foundational truth about ASA firewall is traffic from high to low is permitted, low to high not permitted.
Is this true to every vendor?
Every vendor, but they will have a different way to measure. Here, the security level number is used here. And likewise, different vendor have got different things to check. Concept is same.
Could go back up. Here, you said
You want the zone-based firewall or what you are looking for?
here zone-based firewall will not come into picture.
Yeah.
Okay, it's because of the security level of the zone.
Yeah. In zone-based firewall, you don't have any security. All are 0. All are untrusted. All zones are untrusted. Here,
It's not zone-based here.
see, adaptive security level planes, you do have zones. Inside is a zone name, outside is a zone name. DMZ is a zone name, but they have given some policies. If it is inside, you can just freely allow all the traffic. So that's the default policy.
So we need to manually configure the firewall as a zone-based firewall, is it? And then all these zones will be.
Yeah. ASA firewall also got zones. Like you have in zone-based firewall. Tell me. Yeah.
This is little confusing for me. Okay, here in this scenario, this firewall is not a zone-based firewall, correct?
See, every firewall operates by keeping zone. See, I use the you don't call like a feature. See, in router, this is one of the feature. A zone-based firewall is one of the feature. But ASA firewall by nature itself, it is a zone-based firewall. It's nature. Unless you assign a zone to interface, the firewall cannot operate. It's the nature of a firewall, not a feature that you enable.
So we have zone-based firewall in Cisco routers, is it?
Yes. In Cisco iOS router, that is what I was talking in the beginning. In the beginning, I said how to make a router as a firewall. I was not talking a literal firewall. I was talking how to make a router in a cheaper price. I use the word even cheaper price. I have a router. I no need to buy a firewall if I have some financial issue, if I have my company very small, and if I no need that big level security. I no need to go for an adaptive security appliance to provide firewall services if my company is small. I can make use of my existing router. All that I need is a security operating system in it. The operating system should be not the IP service provider or IP enterprises. It needs to be IP security. If I have security version of operating system, then zone-based firewall feature is available. Like you have MPLS feature in IP service provider operating system. You got zone-based firewall as a feature. In that router, you cannot expect MPLS. Again, I'm telling you, this is a router. So when you put a security operating system, it will have a limited routing and limited security, not 100% routing, 100% security. In your service provider router, you cannot expect zone-based firewall there because that has got more of MPLS and more QoS and policies like RSVP, so on.
Zone-based firewalls mainly in enterprises.
Enterprises and service provider security version of operating system. Security operating system you need to have. So when you say firewall, it the firewall will by default have the zones, meaning not by default will have zones. It needs zone to be configured by default, only then it can operate. Without creating zones, without assigning the interfaces to different zones, you will not have ASA functioning. ASA won't function as a firewall. Even though it's a firewall, it won't function. It won't work unless you provide a zone name. To make you understand, I'll give you an example. You go to an interface, give IP address. After giving IP address, you also say no shutdown. And go and check whether the interface is operational. It will not be operational. See, you have said no shutdown. You have given an IP address. Usually in router, when you give IP address and say no shutdown, that interface is usable, right?
Correct, correct. Yes.
You can ping the interface will respond to you. But in firewall, after giving IP address, after saying no shutdown, try pinging that, it won't ping. Why? The IP address that you assign will not be in use unless you assign that interface to a zone name. So that's why I said zones are by nature in firewall. By firewall by nature it will have zone. It needs zone. It will have zone. It needs zone. Otherwise it cannot be a firewall. Whereas routers, they are not by nature zones. They are simply routing devices. They route packet from one link to another link if there is a route and no ACL blocking. But by enabling the feature zone-based firewall, you make the router to act like a firewall. What is that? Don't allow traffic from this zone to that, go to that zone, unless I write a policy. So we'll do a lab first on zone-based firewall on a router. See, this is the reason why I delivered this zone-based firewall first, so that you will know the actual difference between the firewall and the router-based zone-based firewall. So in production, if you are okay with zone-based firewall, you don't need to buy ASA firewall. See, the truth is, I have seen there are many attacks that are easily stopped by just hardening this switches and routers. But because they don't know, they immediately spend money. Oh, we need a firewall. Otherwise we cannot stop these things. No, that's not true. A lot of things can be stopped just by tuning your switches and routers, hardening the switches and routers. So this is one of the things that you should have on a router, is to make it as a firewall. So you don't need to buy a firewall if you know very well that this is what I want the firewall to do, and if you know how to do it, then you can use zone-based firewall to do that for you. You don't need to buy a router. You don't need to buy a ASA firewall. But you are not sure what sort of attack is going to come, who will attack, how the attack. Then you need help. You need to buy the devices that has got inbuilt codings to block and identify and block the attacks. That's why you need to buy ASA firewall, IPS, WSAs, ESAs, Umbrella, FTD, FMC, blah blah blah, ICE, and so on. Anyway, this is the beginning of the firewall course. We'll talk about zone-based firewall again with the lab in the next class. Shall we